We've got a parallel circuit now. We have a parallel circuit with 3 resistors, much like the last problem. If you watch that last one, the one in series, it's similar, but now our 3 resistors are in parallel. Same battery, same resistors, but they're in parallel. And now, but we still want to find the currents through each one of those resistors. So we're going to use a VIR square again, but the VIR square is going to be different. Now there's a trick, because here, if you remember, in series, to find the total resistance, we just added up each of the resistors, or however many we had. In parallel, it's different. If you remember from your reading, let me change that. In parallel, it is to find the total resistance. The 1 over the reciprocal of the total resistance is 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, however many resistors we have. So that tells us we've got to change our VIR square. Our square is going to have to be a little bit different in order to do that. So let's look at our VIR square. So here we go. We're going to do VI, same as before, except now we're going to change it. So we have a 1 over R, and then we have an R. And now we're going to make our table. So let's draw out our table here. Remember, we put in resistor 1, resistor 2, resistor 3, and our total. Okay. Now let's go through what each of the columns does here. So in parallel, the voltage is all the same. In parallel, the currents add. Now this 1 over R, it's going to add up. That was the formula we just did. If we go back to that, see this formula right here? It says, this formula right here says that we add up those 1 overs. So that's why we have this new column 1 over R, and it adds. Also, this last column, this resistance, does nothing. We can't move up and down. That's telling us that we cannot move up and down in this column. In order to move up and down to a new, in order to move to a new row, we have to use one of the other 3, either the V, the I, maybe both of them, like in that case, or the 1 over R. We can't go up and down. So let's go ahead and fill in the values that we know for this circuit. So we do know that that's 12. We know the total voltage in this circuit is 12. We also know that we have 1,000 ohms for resistor 1. We have 3,251 ohms for resistor 2. And we have 2,785 ohms for resistor 3. Okay, so now we've got to find. Now what were we looking for? Let's mark. Let's mark our I's, because we're looking for each one of those. So what do you think? What can we do? Well, let's see. What else do I know? Well, let's fill this in, because I automatically know that voltage is all the same. So that means these are all 12 volts, right? So I'm thinking I can get the I. If I think I'm going to have to, well, I think I can get the I just from the resistances, can't I? Because I know the resistance, I know the voltage. I think I can use Ohm's law and get each one of those currents through that. So let's look at that. Let's see if we can do that. So let's look at Ohm's law. Ohm's law is V equals I times R. If we were looking for I, if you remember, we did this. Those cancel. That means I equals V over R. So I think we can say I1 equals V1 over R1. I2 would equal V2 over R2. And I3 would be V3 over R3. So V1, that's 12 volts over 1,000 ohms. And then V2, that's again 12 volts. Remember, if we go back to our VIR square for the parallel, those voltages were all the same, right? Okay, so we got that. So 12 volts again over R2 is 3,251 ohms. I3, that's going to be again 12 volts over 2,785 ohms. So I think I've got those. So I do 12 divided by 1,000, that's 0.012 amps. Okay, and now let's do our I2, current number 2, 12 divided by 3,251. What is that one? That's 0.00369 amps. And then 12 divided by 2,785 is 0.0043 amps. So these should be our answers, right? That's what we had marked on our VIR square. So let's go back to our VIR square. And there it is. And so we have that current in box 1 is 0.012 amps. Current across 2 is 0.00369 amps. And the current across 3 is 0.0043 amps. Okay. And so now we've got our answers. So we can just stop there, or remember, in our last VIR square, we could use the rest of the squares and check the answer. So we're going to go ahead and do that. So remember, this column, this current column, right here, it says it adds to a total. So let's go ahead and add those up. So we have 0.012 plus 0.00369 plus 0.0043, and that equals, I'm going to draw a line here, you'll see why later, 0.01999. Okay, so there is our there's our current total from that. Now to check that, what we're going to have to do is we're going to have to do a number of calculations here. That's okay. We're going to have to calculate each one of these resistances and get a total, and then we'll use Ohm's law to get our answer right here of V over R. Okay, so we've got to get our total resistance first. So remember, we've got to do 1 over each one of those. So let's come here and let's find our total resistance. So remember, in parallel, 1 over RT is going to be 1 over R1 plus 1 over R3 plus, or 1 over R2 plus 1 over R3. So that means 1 over the total resistance is 1 over 1,000 ohms plus 1 over 3,251 ohms plus 1 over 2,785 ohms. Okay, so 1 over RT is, let's do this, so 1,000, 1 over 1,000 plus 1 over 3251 plus 1 over 2785 is 0.00166667. Now remember, that's 1 over. I've just added these up in decimal form. So let's put this step in here so you can see this. So this is 0.001, and that's 1 over ohms plus 1 over our 3251 is 3 times 10 to the negative 4th, 1 over ohms, plus 1 over 2785 is 3.59 times 10 to the negative 4th. There's some decimals here, but I'm leaving those off because we're running out of room. So that's our 1 over. So that means RT, we just take 1 over that, right? So 0.00166667, we take 1 over that, and that is 599.9988 ohms. So there's our resistance. So really, we're going to round that, say 600 ohms. So if we go to our VIR square, let's go back to the VIR square. And so that's 600 ohms right here, right? 600 ohms right there, okay? And we said that this was just 1 over 1,000, 1 over 3251, 1 over 2185, right? That's what we got. And this was 0.00. Let's see, let's go back and look at it. See if I can get it. 0016. There we are. 0.016667. Right? Okay, so now we can use our Ohm's law and figure out what the current is, because we have 12 volts and 600 ohms. So let's go calculate that. So we have V equals I times R. But remember, again, we're looking for I. We've done this a few times. That's V over R. So the total current is our total voltage of 12 volts divided by our total resistance of 600 ohms. So 12 divided by 600 is 0.02 amps. So now let's go back to our VIR square, because that's the whole reason we're doing this, is to check it. And that's we said that was 0.02, which is pretty close to 0.01999. So that means we got it. We're feeling confident. So you can see we didn't have to do that, but we can check our answer and make ourselves feel confident. So our answer is just our currents, right? Right here. There's what we would write down as our answers, each one of these currents. Got it? Hopefully that'll make things a little easier for you in organizing these when we get multiple resistors.